Hey everyone, happy Tuesday. Of course, I'm not there today, but I still want to continue practicing with you guys graphing quadratic functions. So today is day number 2. And in case you missed it as well yesterday, so we're going to jump right into it. The plan is I want you guys to watch this video. I'm going to do 2 examples, and then after those 2 examples, you guys do have a class activity. My sub should have the answer key. That way you guys can check. If everything's perfect, you guys know the deal. Go ahead and turn that into the inbox. So let's just jump into it. So again, graphing quadratic functions. Again, this is going to be the expectation by the end of the week. Can you graph a quadratic? Again, what makes this a quadratic is that we have x to the second power. Now, whenever you graph a quadratic, you end up with this U-looking shape right here, which we call a parabola, right? So again, that's what you should be expecting to get today. If you get something funky like, I don't know, something weird like that, something went wrong, one of your points is off, right? So again, we should be expecting to get that U-looking shape. Now again, it could be a lot thinner, it could be a lot wider, it could also be facing down, but the idea is still the same, that we have that parabolic shape. Um, and again, the idea is we are going to use a table of values. So I'll give you guys all your x's. Your job is to plug those in, right? We're going to plug those in for our x's here and here. We're going to work it out, get all our y's. And once we have that, we're going to go through and graph using a table of values. Again, it's the most basic way to graph any function. And so that's what we're going to practice. So again, one more time. The idea here is you have a function. You have this function right here, this equation. We're going to go through and we're going to plug in our inputs. Those are our x's. Remember our inputs, outputs. So you plug in all your inputs. And the function does a little bit of work, and then of course it's going to spit out those y values, those f of x. Now, once we have all those coordinates, we're going to go through, right? Once we have all those coordinates, we're going to go through and graph it. And again, one more time, we should be getting that parabolic shape, which we call a parabola, right? That U cup looking shape. Careful not to accidentally make it look like a V. All right, so here is example 1. So again, make sure that you guys are following along. They should go inside of your notes, and I'm just going to jump right into it for the sake of time. I'm trying to keep this video pretty short. So again, it says graph f of x equals x squared minus 2x minus 1. Well, we're going to use the table of values again. I give you guys all your x's, and then we're going to figure out all our f of x's, all our output, all our y's, and then we should be able to graph it. So I'm going to show my work here. And again, the idea is everywhere that I see, if I can write, there we go. Everywhere that I see an x, everywhere that I see an x, everywhere that I see an x, we are substituting our x values here. So let's go through and do the first one here. I'm going to say f of x no longer. I'm going to say f of -1 is equal to, I see x again there, so we're going to put -1 to the second power. Again, after that, there comes a -2 in our function. We see an x, so again, I put -1 in parentheses, and of course, -1 here at the very end. All right, now we're going to take this in pieces here. F of -1, and again, that doesn't change. That's just a little reminder there that, hey, what are we dealing with right now? We're dealing with the first input, our first x. So eventually it'll give us our output. Again, that's just a placeholder. We just drag that down. Now let's see what happens here. What is -1 to the second power? Again, like I had a lot of you guys yesterday giving me something like -2. No. -1 to the second power. I'll write it up here. What does that mean? It actually means that you have -1 times another -1. Well, what's -1 times -1? +1. So be careful there. I have people actually giving me -2. So please be careful. All right, the next thing we're going to multiply here is -2 times that -1 in parentheses. Well, -2 times -1 is +2. And then we bring down the -1 at the very end. All I have to do now is add and subtract these 3 numbers. So that is going to give us f of -1 again is equal to, and here I have 1 plus 2. Well, 1 plus 2 is 3, and then 3 minus 1 is going to give us back down to 2. So there it is. When our input is -1, our output is 2. Let's keep that going. I'm going to try that one more time. I'll show you guys real quick. Let me break up my work here. Let's move on to now f of 0. F of 0. Some of you guys found the shortcut with 0 yesterday, which was really great. So f of 0 is equal to, I see an x. We're going to plug in a 0. 0 to the second power. -2. Again, I see another x, so we put a 0, and then -1. Bring that down. Let's go through and work this out. F of 0, again, that's staying the same. What is 0 to the second power? That's 0 times 0, which is 0. What is -2 times 0? That's just going to give us 0. You put plus or minus 0. It's all the same, right? Adding and subtracting 0 doesn't change anything. And we drag down the -1. All right, so what's 0 plus 0 plus 1? That tells us that, hey, f of 0 is equal to 0 plus 0, which is 0, minus 1, gives us negative 1, right? So that's the idea there. That's the idea. Now, I'm going to keep this going a little bit longer. I'm going to show my work for all this. I'm going to pause the video, do some little movie magic, and then I'll show you guys the rest of these 3 outputs right here. So again, if you want to pause the video, practice this. I highly recommend it. Try it on your own. All right, so with the little movie magic there, I went through and completed the rest of my table of values, right? So here you guys can see it where I plugged in 1 right there. Here I did number 2, and then here I did number 3. So again, feel free to go through and check your work, check your work. That's how I got that -2, -1, and 2. And again, like I said, as you do so many of these, you should hopefully start to kind of recognize a pattern, because I don't know if you guys realize this, but again, parabola, there is symmetry, right? There's symmetry. If I can slice that parabola down the middle, it's a copy on the left, is the same copy on the right. So hopefully you guys can kind of see that with the numbers that's kind of happening right here. So let's go through and now actually graph it, right? The whole purpose of this was to graph this parabola. So let's move over here to the next slide. So I kept the numbers the same here. I just went through and I copied them over. And I have my nice little graph here. So again, I'm going to ask you guys, take a minute, draw yourself a nice coordinate plane. Again, use the edge of your ID, your phone, one of our calculators. Just go ahead and set yourself up, right? And again, I always get this question, how far should I go, Mr. David? How many little tick marks should I do? Again, look at, scan that table. What's the biggest number we have here? I see a 3. So again, I wouldn't go much further than maybe like 4 or 5. But again, give yourself plenty of space, guys. Some of you guys are drawing little coordinate planes like that, trying to graph it. You're making life so much more difficult than it has to be. Be generous. Draw yourself a pretty large coordinate plane. It'll make life easier. All right, let's go through and actually graph it then. So I went through. I plugged in all my inputs into my function. We got our outputs. Now it's time to actually graph these. Well, don't forget again, your x value, your first value is going to tell you guys left and right. If it's negative, we go left. If it's positive, we go right. Your f of x or your y here, that tells you your up and down, your rise or your fall. If it's positive, we're going to go up. If it's negative, again, think of bank accounts. My bank account goes down every time I see a negative. Let's go through and actually plot these points then. Where is -1, 2? Well, we're going to go left -1. And then we're going to go up 2 spaces and we put a point right there. That's our very first one. The next one is 0, -1. 0 left or right, we stay in the middle, but we do go down -1, -1, -1. Let's keep it going. 1, -2, that means 1 to the right. And then -2, but that's -2 is down. Keep this going. 2, -1, we go 2 to the right, -1 down, and I can already start to see kind of my parabola forming, right? You can kind of see it shooting back up. The last one is 3, 2. That means 3 to the right, but this time +2 up. So there we have it. So there's the left-hand side of the problem. And again, this keeps going on and on forever. If I could actually have enough space and time, I could keep this going on for a good while. And again, I'm going to reflect that. I'm going to copy it over to the other side. There's that nice symmetry. If you take a look and kind of slice this problem down the middle, and we get that symmetry, that will eventually lead to more shortcuts. So again, I need you guys to pay very close attention to that. And there you go. That is the expectation, guys, on how to graph a function using a table of values. Let's try that one more time. We're going to try it with a slightly different problem. So again, take a minute, copy this function here. Notice the difference. The last one. That was a positive right there, right? That was a positive. I want you guys to take a look at the way the parabola was facing, right? So take a look at this one here. You actually have that negative right there. There's actually like that -1. We're going to see how that actually affects our parabola in this example, right? And again, those shortcuts are what we're trying to find. We're trying to find those patterns so we can eventually get to shortcuts. All right, let me go through and actually work it out. So again, I'm going to take my first x value here, -4, and I'm going to plug it in for all of my inputs, all of my x's, and I'm going to work it out just like that last one. This time it's going to be a little bit awkward though. We're going to say f of -4 is equal to, and again, there's that -1 right there technically. Again, if it helps you, I would absolutely recommend that you write it down. So I'm going to put -1. That's part of my function. And then instead of the x, we're going to go ahead and put parentheses, and I'm going to plug in the -4 in there. All of that to the second power. After that, we see the -6. I run across an x, but again, we're going to put -4. And then all of that -4 at the very end. So it's going to look a little weird, but we can still work this out. So we're going to say f of -4, that does not change. what is going to be a little awkward is this section here, So what I'm going to do first is I'm going to do the exponent. PEMDAS order of operations says we have to do the exponent first before we multiply it by that -1. So one more time, what is -4 to the second power? That's not -4 times 2. That is saying -4 times -4. Well, that's going to give us +16. But that's only this section right here. That's what's giving us that +16. Well, what's +16 times this extra -1 there? That's going to eventually give us -16. That's what we want to go ahead and bring down there. All right, let's keep this going. What is -6 times -4? That's +24. And we bring down the minus 4 at the very end here. Let me go ahead and bring down f of -4 is equal to, what is 24 minus 16 there? That is going to give us 8. 8 minus the 4 is going to give us 4. So we're sitting here at -4, 4. All right. I'm going to try to keep that going for the rest of these problems. Again, I'm going to do a little bit of movie magic. So give me a second. I'll show all my work here for you. All right, let me show one more here just in case you missed it. So I went through and I plugged in -3. So I'm going to bring down f of -3 is equal to, and again, I'm going to work with this section, but I'm going to do the exponent first. So what is -3 to the second power? Again, that means -3 times -3, which is positive 9, right? -3 times -3 is going to give us +9. But then when we multiply it again by that -1 sitting in front, it turns it back into a -9. -6 times -3 there is +18. Careful with your signs. Bring down the -4. All right, let's keep this going. We're going to end up with f of -3 is equal to, well, what is 18 and a -9? That gives us 9. 9 minus 1 more 4 there is going to give us 5. So that is our output value. All right, now I'm going to go through because I'm running out of time here. I'm going to fast forward and give you guys all the work. I'm going to show my work here in a minute. All right, guys, there you have it. So again, there's the rest of my work. Those are the rest of my output values. What I'm going to go through and do now is actually graph it with you guys. So again, I just went through and I recopied all those numbers again, making sure I recopy those correctly. Let's go through and actually graph our parabola here, right? So let's go ahead and again, remember the first one is left and right. The second coordinate, part of the coordinate tells you up and down. So where's -4, 4? We're going to go left -1, 2, 3, 4, and then up +1, 2, 3, 4. And we put our very, very first point. Next one, -3, 5. We go left 3 and up 1, 2, 3, 4, 5. The next one is -2, 4. So we go left 2 because it's negative. We do go up 4. Lastly, here we go -1 to the left and up 1. And the last one here is 0, -4. We stay at 0. We go down 1, 2, 3, 4. Now, what I want you guys to notice is we don't actually get a full parabola. We kind of see the half on this side. So how could I get the other half? Well, remember, there's that nice symmetry, so we can kind of copy it to the other side. Notice this is 3 spaces away. I'm going to go 3 spaces on the other side. Whoa. 3 spaces on the other side here. And take a look. This one was 2 spaces away. I'm going to try to copy that over on the other side, and we get our other half of the parabola. So again, if that ever happens, guys, there's that nice symmetry that lets you copy it over. Really, you only need half of the parabola. As soon as you have half, you can copy the other half right over to the other side. All right, guys. Now, the other thing I want you guys to notice is remember that value at the very, very front. When it's negative, take a look at what happened to this parabola. Which way is it pointing? Right? It's a sad face. It's pointing, it's a frown going upside down. Why does that happen? What does that happen? If your a at the very beginning here, this is ax squared. If that a is a negative number, it's going to force the parabola to go face down, right? If it's ever positive, just on the last example that we did, example 1, it's going to be facing up. So again, those are some shortcuts there. All right, guys, so here's the expectation for you guys. Again, you guys have these four problems to practice on. All right, so again, I do expect you guys to complete your tables and then, of course, graph each of these functions. I should see four parabolas. When you are done, please check your answers with my sub. And then if everything's perfect, go ahead and turn it into the inbox. Actually, if you guys want to check these values here right before you start graphing, feel free to run over to the sub and ask just to double check, right, making sure that we're graphing using the correct coordinates. All right, guys, have a great Tuesday. I'll see you all tomorrow.